Hello everybody, it's Mrs. Pound and I'm back with more with chapter 3.1 on solutions. We're going to take a look at today at oceans and saltwater in section 313. So our objectives are to identify solutes in the ocean, explain what factors affect the salinity of the oceans, and describe methods of desalination. So salinity is the amount of salt in water. And if we take a look at this picture, all of the white stuff down here, that is not sand. That is actually salt. This is a picture from the Dead Sea area in Israel. And that is not sand on the beach. That is, in fact, salt because the Dead Sea has very high salinity. And we'll talk about that in a little bit. Processes that bring salt to the ocean or to any body of water like the Dead Sea are runoff, so water flowing over the land into streams, then into rivers, and then into the ocean. Groundwater flow, so there is water underground that is actually flowing into the ocean, and river flow. The salt gets in there from the land. There are minerals on the land that get into the water and also minerals in the groundwater that go into the oceans. Elements that make up salts in the oceans include magnesium, chloride, calcium, and sodium. Now, I know you're pretty familiar with the fact that sodium chloride would be in the oceans because that is table salt. And if you've ever been to the ocean, it tastes like table salt. It tastes salty. But other common salts that are in the ocean are magnesium chloride and calcium chloride as well. Now, the Dead Sea is saltier than the oceans because it loses most of its water through evaporation and there is no outlet. It's also a lot smaller than the oceans, so when that runoff, that groundwater, the river flow and everything go in there, it doesn't go anywhere. It doesn't have an outlet. It's not like most lakes and different things have an outlet, a river that goes out of them, but the Dead Sea does not have that. And so the only place for the water to go is to evaporate. And so all of that salt stays in there. That salt does not flow out anywhere. It just stays there. And so that's why the Dead Sea is so salty. Plus, it's a lot smaller than the oceans. So you have that salt going on in there and it's becoming much more concentrated. Why do salinity levels vary throughout an ocean? The salinity levels are not the same in all of the oceans and it can vary. I want to go back here just for a minute too. Let's go back to the Dead Sea for just a minute. Because the salinity is so high, even if you can't swim, you're going to float in this water, which is pretty cool. The same thing with the Caribbean. You're going to float in the water without much trouble, even if you don't know how to swim. So let's go back to why do salinity levels vary throughout an ocean? Salts are brought into the ocean with surface runoff, groundwater flow, and river flow. We already know that. And so you might have, where all of that is flowing into the ocean, you may have higher salinity levels due to the fact that that's where all of that is entering in. Convection currents in the ocean stir up the salts. So depending on where you are in the ocean, remember we taught convection currents move like this. Warm water rises, cool water falls, and so you get this movement like this in the ocean. And that will actually stir up the salts. Now, if they're well stirred, maybe the salinity is less because it's being evenly distributed. If it's not well stirred, then you might have more salinity in certain areas because it's just not stirred up, kind of like all the salt going to the bottom of a beaker or a glass when you're adding salt to water. When water evaporates from the surface, salt is left behind. And so you can see here, this is actually a picture of a salt flat. And you can see the salt crust on the top of this water, leaving the salt behind, and only the water evaporates. And so that will increase your salinity. This is what's happening at the Dead Sea. Different water temperatures can hold different amounts of gases and solids. So we see here some icebergs in the background. So this is very cold water, and we did an experiment the other day where we saw that cold water does not hold as much solute as warmer water. So in our Arctic areas, perhaps the water has less salinity due to the fact just that it does not dissolve as much. And harvesting salt from the ocean can change salinity levels. So here we have a picture of some salt harvesters. I don't know if this is Vietnam or Korea, but it is an Asian country. And they are taking salt out of the ocean. So that can affect, if you're taking salt out of the ocean, that can affect the salinity levels. You can lower the salinity, or the fact that they do have this production area, maybe that's an extra salty area as well. So all of those affect it. Now, we can also take salt out of salt water, and we call this desalination. This is the process of removing salt from ocean water to obtain fresh water for drinking, irrigation, or industrial use. They commonly do this in, say, the Arabic nations, where it's a desert nation that is close to salt water, but they don't have a lot of fresh water of their own. And so they will have desalination plants that will remove the salt from the water. And you can see down at the bottom of the picture this crusty salt, and there are holding tanks that do various things with the water. Now, one common process, the most common that they use at these desalination plants, is the process of reverse osmosis. So desalination process that forces salt water against a membrane so only water goes through it. So they use membranes and they're forcing the water. Now, their machinery would look a lot more complex than this, but we just want to get the idea. So there is salt water in this side of the tube, and they are applying pressure to it to push it through a membrane that will take the salt out but allow the water to go through. And so then we have the water going through here, and that is fresh water. It has had the salts removed. So that is the process that they would commonly use at these desalination plants. Okay, so our objectives were to identify some solutes in the oceans, those elements that we talked about, explain what factors affect the salinity of the oceans, and there were a number that we talked about, and describe methods of desalination. We did focus on reverse osmosis. You could also do distillation, which would involve evaporating the water and then collecting the water, boiling it off, collecting the water vapor. But that is just much more intensive and does not happen at the big desalination plants where they're collecting a lot of fresh water. So don't forget your 5 questions, and I'll be back with more about solutions.